Alright, in 18th question again we have a similar question about these complicated relations. So bear in mind that if a question comes like this in an objective exam, you can proceed with your intuition. Okay, so you can build an example where this works in your mind and then do with it. You don't actually have to give a proof. You get marks only for the correct answer. So what we have here is that set of preferences which obeys asymmetry and negative transitivity. So you see, asymmetry is pretty obvious that if a bundle is more preferred to the other bundle cannot be more preferred to this bundle. Okay, so that's asymmetry. So that will be obviously applicable for normal preferences. Now negative transitivity says that if x is more preferred to y, then if you add a new bundle z, then either it's going to be less preferred to x or it's going to be more preferred to y, which is again pretty obvious. So you cannot have a bundle which can be less preferred to x and simultaneously sorry, you cannot have a new bundle which will be you see it cannot be better than x but worse than y. Okay, so negative transitivity, all it says is that x is better than y. So what negatively transitive says is that x is better than y. So if you add a new bundle z, you cannot have that z is better than x and worse sorry worse than y. So these are pretty obvious kind of things which any normal preferences would yield. So then what they ask you is transitivity of weak preference. Now I know that if normal preferences hold, normal preference relations hold, then my weak preference should be transitive. So you don't need an actual proof here, but obviously it's our job to give a proof here, so I'll give you a proof. So again, the proof proceeds in a similar manner. So we are going to assume that this preference relation, weak preference, is not transitive. So transitive, what that means is that you have x weakly preferred to y and y weakly preferred to z, but negation of x weakly preferred to z. Okay, so x weakly preferred to y means negation of y strictly preferred to x, and negation of z strictly preferred to y, but negation of z strictly preferred to x, which is basically equivalent to saying that z is strictly preferred to x. Okay, so we have the strict preference as asymmetric and negatively transitive. So yeah, so we have the strict preference as asymmetric and negatively transitive. So let's see what this means. Okay, so this is basically negation of y strictly preferred to x or z strictly preferred to y, right? So that's how the negation flows. So if you put negation inside the bracket, it is going to change or into and it's going to spread over. So we have this thing true and z strictly preferred to x. Now z strictly preferred to x, if you apply negative transitivity here, okay, if you apply negative transitivity here, what this means is that either of these two things are going to be true. So z is strictly preferred to x. So instead of x and y, you have z and x, and y is now the z. So so if you add a new variant y, so either y will be more preferred to z, right? Either y would be more preferred to z, or x would be more preferred to y. Right, so if let me just check, x, no, sorry, I got confused. Either z is more preferred to y, or y is more preferred to x, right? That's negative transitive, x preferred to y, so either z is below the x or z is above the y, right? So here you would have the new variant, the z is the higher preference variance and y is the new addition, so either you would have z preferred to y or y preferred to x. Now as you can see that this and this, they make a contradiction. Okay, so that's why you have a contradiction, so your assumption is false, so your weak preference is transitive.